In the world we live in, there's this incredibly powerful set of tools that's quietly shaping just about everything, from our security online to our actual health. So today, we're going to pop open that toolbox and really get to know the core algorithms of machine learning and see how they're being used to solve some of the world's biggest challenges. Okay, so think about this for a second. On the surface, these things seem totally unrelated, right? You've got digital security, environmental science, and then information integrity. So what on earth could possibly be the common thread that ties them all together? And the answer is machine learning. But here's the thing. You shouldn't think of it as some single magic solution. A much better way to picture it is as this super versatile toolbox, just packed with specialized digital instruments, where each one is perfectly crafted for a very specific kind of problem. So if machine learning is a toolbox, what's actually inside? Let's get right to it and meet the key players, the algorithms that you see being used over and over again to solve these massive problems. Here they are, 5 of the most common tools in the box. First up, you've got the random forest, which we're calling the powerhouse, because it uses hundreds of simple models to make one super accurate prediction. Then there's the decision tree, the sprinter, which works like a lightning-fast flowchart to classify things in a snap. We've also got the support vector machine, the divider, which is just brilliant at drawing a line and cleanly splitting data into different groups. Next is logistic regression, the classifier, a real reliable workhorse for all sorts of classification jobs. And finally, the convolutional neural network, or CNN, the visionary, which specializes in, you guessed it, seeing and recognizing patterns in images. All right, so we've met the crew. Now let's see them in action. We're going to start on the front lines of our digital world, where these algorithms are being deployed every single day to keep us safe. And what's really cool here is you can see how different tools are picked for different threats. For something like malware detection, the powerhouse random forest and the speedy decision tree are go-to choices. But for spotting fake images, well, that's when you bring in the visionary, the CNN. And for complex intrusion detection, you're often seeing hybrid models, using tools like k-nearest neighbors, or KNN, which basically just classifies something based on who its closest neighbors are. It really drives home this one key idea. It's all about picking the absolute right tool for the job. But hey, this toolbox isn't just for cyberspace. Not at all. These exact same algorithms are making a huge, huge impact in the physical world too. Everything from predicting health outcomes to managing our environment. This slide is where you really see just how amazingly versatile these things are. The very same random forest and decision tree algorithms that fight malware are also being used to make sure our water is safe and to make city traffic flow better. And look, in traffic optimization, you'll even spot SVR, which is support vector regression. It's kind of like a cousin to the SVM we met earlier, but for predictions. And there's our visionary, the CNN, this time recognizing hand gestures. These aren't just one-trick ponies. They're fundamental problem-solving engines. Okay, so with all these options, how in the world does a data scientist actually choose which one to use? Well, a lot of the time, it boils down to this really crucial trade-off. It's a classic face-off between getting the most precise answer possible and getting a pretty good answer really, really fast. So let's compare 2 of our most popular tools head-to-head. On one side, you've got the random forest, our powerhouse. Its whole game is achieving incredibly high accuracy by essentially taking a vote from hundreds of individual decision trees. It's the wisdom of the crowd. On the other side, you have just one of those decision trees, our sprinter. It's blazing fast and super efficient, but it might not always have that same pinpoint precision as the entire forest. And hey, don't just take my word for it. The research we're looking at consistently points to random forest when accuracy is the #1 priority. But it also gives a big thumbs up to logistic regression and decision trees for their awesome balance of being both fast and accurate. This chart just lays it all out perfectly. You can see that accuracy bar for random forest just towering over the others, but its speed is, well, it's just okay. Meanwhile, decision tree and logistic regression offer this really compelling sweet spot. So here's the bottom line. There is no single best algorithm. It all depends on what you need. Do you need the perfect diagnosis, no matter how long it takes, or do you need a quick, reliable one right now? But what if you didn't have to choose between just speed or accuracy? What if you could actually get the best of multiple worlds by getting these tools to team up? Well, that's where things get really, really clever. It's a technique called an ensemble method. And honestly, the core idea is pretty simple. A team of diverse experts is almost always going to outperform one single genius working alone. So by combining different models, you can boost their strengths and cancel out their weaknesses. So how does it actually work? Well, it's kind of like a three-step recipe. First, you pick your team of models. For instance, one study combined a random forest with a CNN to recognize hand gestures. Next, you use a special technique to merge what they all think. And the result? You get a final model that's way more accurate and reliable than any of its individual parts could have been on their own. So if there's just one thing you take away from all of this, let it be this. Excellence in machine learning isn't about some quest to find one single magic algorithm that solves everything. No, it's about craftsmanship. It's about understanding the entire toolbox and knowing precisely which tool or combination of tools to pull out to build the perfect solution for the problem right in front of you. We've seen how this incredible toolbox is already taking on huge challenges in cybersecurity, in healthcare, and the environment. And that leaves us with a really fascinating final question. As these tools get even sharper, and as we get even better at combining them, what's the next monumental problem we should task this incredible toolbox with solving?